we have selected some topics now which I think would be very helpful, especially when it comes to the clinical chemistry and also in preparation na rin no, for the future na board exam. Okay, so para in preparation na rin to that, okay, we have selected some topics no that might be helpful for you guys. Okay? Pero either way, we'll be having clinical chemistry and I hope dyan sa inyo yung notes natin. We'll be starting off with the basic ones, more of pang general laboratory topics yan. We'll be having instrumentation, and then we would also have laboratory mathematics together with the quality assurance. And quality assurance is quite surprising ano kasi ito yung isa sa mga sa mga topics na minsan na neglect ng student. Okay, pero they would be surprised na marami palang questions about it. And the thing about the quality assurance is hindi lang siya sa clinical chemistry. You can actually find them across different subjects now when it comes to the board exam. Okay, so we really have to cover no the quality control, quality assurance topics which we will be tackling down later on. And then after that, we'll try to look for the analytes. Okay, particularly we will be focusing mainly on the three major analytes natin. Okay, so three major na analytes that we have: the carbohydrates, the proteins, and the lipids. Okay, and if time permits, we will try to tackle or run down some of the other analytes no, that we detect in the laboratory. Okay, that is kung kaya pa ng oras. Okay, pero either way, without further ado, let us begin the discussion. By the way, in case na may technical problems, please do send me a message dun sa ating chat box. Okay, in case lang naman na may problem, for example, medyo may technical problem on my side or on your side or medyo nagsisirang plaka yung aking connection. Okay, please do inform me no, para ma-check natin or ma-repeat natin kung ano yung mga items that have been missed out. And in case na meron din kayong mga questions, you can also type it down dun sa ating chat box na okay para ma-clarify natin. Kasi ang problem with clinical chemistry, may mga items na iba yung sinabi ng isang libro sa sinabi ng isang reference. Okay, so just to clarify things out, para ma-share ko rin yung reference ko sa inyo as to why we have mentioned that particular thing. Okay, mas maganda rin no, kung ma-ask ninyo yung question. Okay? So I'll try to reply as fast as I can no, dun sa ating chat box. Okay, pero either way, start tayo ng clinical chemistry discussion. And again, we will be starting off the discussion with the first part: instrumentation and automation. Ito medyo universal topic din to. No? Medyo universal topic din to kasi itong mga instruments na tatalakayin natin are not just really confined sa clinical chemistry. In fact, makikita nyo rin to sa iba eh. Makikita nyo rin to sa ibang mga subjects. Like for example, yung turbidimetry, ginagamit din yan sa micro. Ginagamit din yan sa hemostasis. Tapos yung ating fluorometry, hindi lang din naman yan sa clean chem ginagamit. They're also used in other areas. Reflectance photometry, ginagamit din sa AUBF, particularly sa reagent strip readers natin. So itong mga topics natin about instrumentation are also a bit universally accepted. So we'll try to focus more no, on what we have to focus, particularly yung mga items na nag-a-appear sa clinical chemistry. Okay, by the way, I'll be typing some items on the chat box, so please do be mindful of the chat box natin. Okay, kasi yung ibang hindi ko masusulat on screen will be typed down or written down sa chat box natin for your reference natin. Okay? Pero either way, we won't be able to tackle all the instruments, pero dun tayo sa pinaka-basic. The most basic instrument that we have is yung mga instrument that measures light, and we would usually call them photometric na instruments. So from the word photometry, what does photometry mean? From the word photo, which means light, and metry, which means measurement. So sa photometry, we're practically measuring light. Okay, so we are practically measuring the light. Okay, so the question is why? Bakit tayo nagme-measure ng light? Okay, why do we even bother measuring the light? Okay, di ba we're supposed to measure the analytes? Are we not supposed to measure the glucose, the triglyceride? Di ba we are supposed to measure the analytes? So how did we end up measuring light? Anong connect? Okay, anong connect ng light sa concentration ng glucose? Anong connect ng light no, sa concentration ng mga analytes natin? Okay, so dito let's try to check the connection. Okay, the interconnection between the light and yung ating yung ating analyte of interest. Okay, so dito let's try first by defining what light is. Okay, so ano ba si light at bakit ba natin kailangan i-measure yung ating light? Okay, so start tayo by defining what light is. Okay, so light is definitely a form of energy and it travels in the form of waves. Okay, so they are considered as form of energy. They travel in the form of waves. So therefore, kung i-picture natin yung light natin, so wave siya na ganito. Meron siyang may mga ups, meron siyang mga ups, at meron siyang mga downs. Okay, so ang light daw ay parang buhay, may mga ups at may mga downs. Okay, so they travel in the form of waves. Now, what do we call this high point? Anong tawag natin dito sa upper portion? Sa up na portion ng ating wave of light. Okay, usually we call it the peak. Sa ibang libro, they call it the crest. Okay, so peak or the crest refers to the high point. The high point ng ating light. And what about the lowest point ng ating light? Okay, what about the lowest point ng light natin? We usually call it the trough. Okay, the trough or the trough. Okay, so trough or the trough, whichever way you want to pronounce it, okay, that would be the lowest point ng ating light. Okay, so peak is the high point, trough or trough is the lowest point of the light. And itong peak at saka trough na to, na-mention din yan, or meron din tayong similar terms like that sa TDM. Di ba sa therapeutic drug monitoring, may dalawa tayong specimen. Si peak na sample at saka si trough or trough na sample. Okay, which basically is similar to this. Okay, kapag peak, yun yung highest point or highest concentration ng drug sa therapeutic drug monitoring. Yung trough or trough naman, dun mo makikita yung lowest concentration ng drug in the circulation. Okay, pero we'll try to deal with that later on. Pero for now, yung peak natin is the highest point of the light and the trough or the trough is the lowest point ng ating light. Okay? However, aside from being in the form of waves, how else do we describe the light natin? So, ang light natin, they can be expressed in nanometers. Particularly, ano ba yung minimeasure talaga ng nanometers natin? Actually, nanometers, from the word itself, meters, it actually pertains to distance. Nano means very short, so nanometers pertain to very short distances. Okay, so very short distances. Ma'am, ano ba yung very short distances na yan that is being measured by the nanometers or being expressed in nanometers natin? Usually, ang nanometers natin, they would actually represent the distance from here to here. Ano bang tawag natin dito sa distance between two consecutive peaks of the light natin? Okay, we would usually call that the wavelength. Okay, so ito yung tinatawag nating wavelength. So how do we describe wavelength again? Wavelength refers to the distance between two consecutive peaks of the light natin. Okay, so two consecutive peaks of light, wave natin, yung distance between the two of them, we call that the wavelength. And ano daw pala yung unit, recall question to, unit of expressing the wavelength natin? So they're usually expressed in nanometers or nm. Okay, so unit of wavelength, the unit between the distance or the unit na ginagamit natin to examine the distance between two consecutive peaks of the light wave, usually we express that na in terms of nanometers. Okay, so recall questions in nanometers ha. Yan yung unit natin for expressing the wavelength of the light. Okay? However, aside from this, what else should we know about the light? So ang light daw, they are usually expressed in wavelengths and wavelengths is usually expressed in nanometers. So why do we need to bother measuring those very short distances? Why do we need to measure those very short distances? Okay, para saan ba si wavelength? Why do we need to know the wavelength? Well, ang wavelength kasi is connected to the energy. And if we were to actually describe the wavelength and the energy, ano nga palang relationship ng wavelength with the energy of the light? Another recall question. Wavelength, laging tatandaan, it is inversely proportional to the energy of the light. Okay, inversely proportional. Kaya nilagay natin siya sa denominator. Kasi usually sa formula, if anything is on the denominator, usually they are inversely proportional. Laging tatandaan ha, kadalasan sa math, kapag ang isang bagay ay nasa numerator, okay, magagamit nyo naman to sa lahat ng bagay. Kapag nasa numerator ang isang bagay, you can say that they are directly proportional. Okay, pero pag sila naman ay nasa denominator, they would be inversely proportional. Okay, so laging tatandaan ha, sa formula, kadalasan pag nasa numerator, directly proportional. Pag nasa denominator, inversely proportional. So in here, we can somehow say that the wavelength is inversely proportional to the energy ng ating light. So ano ibig sabihin nun pag sinabing inversely proportional? Ibig sabihin kapag mataas ang wavelength, ano masasabi natin sa energy? Mababa yung energy. In short, kapag mahaba yung wavelength, okay. So kapag long yung wavelength, okay, long yung wavelength, ibig sabihin lower yung energy. Okay, kasi they are inversely proportional. So ito drawing natin parang ganito siya. Okay, so if we were to draw it out, okay, taka. Okay, lumalabas yung ating mahiwagang pen. Ay, teka wait lang ha. Nagloloko yung aking teka time out lang. Okay. Teka wait ah. Yung aking pen ay nagloloko. Ay, nawala. Teka wait lang. Yung aking writing pad kasi. Let me share it again. Yung ating screen. Screen. Oh, yeah. Ayan. Okay, so ano na bang nabanggit natin? Ating ayan, yung ating laser beam. Okay, so ayan. So ano nabanggit natin about the wavelength of the light natin? So again, wavelength is inversely proportional to the energy, meaning the longer the wavelength is, okay, kapag mahaba yung wavelength, inversely proportional, what would happen to the amount of the energy? Pababa yung energy. So longer wavelength would mean lower energy. And syempre, the opposite is also true, no? Kapag shorter naman yung wavelength, okay, shorter naman yung distance between the two consecutive peaks of your light, inversely proportional, tataas naman yung energy. Okay, so lagi tatandaan, shorter wavelength would mean higher energy. Now, don't forget that part. Bakit? Kasi connected yan later on sa recall question natin. Okay, so huwag kakalimutan that wavelength is inversely proportional to energy. Magagamit natin yan later on when we go to the different spectra ng light natin at saka when we go to fluorometry later on. Okay, so huwag kakalimutan, wavelength is inversely proportional to the amount of the energy ng ating light. Okay? However, aside from this, ngayong alam na natin kung bakit natin kailangang i-measure yung mga very short distances na yan. So now that we know the importance of the wavelength, the next big question now is, anong connect ng light natin dun sa ating topic? Okay, anong connect nito dun sa glucose natin? Anong connect nito dun sa ating alin? Anong connect nito dun sa ating mga analytes? So how do we use the light to measure the analyte of interest? Okay, so ganito yan. Laging tatandaan, ang light natin, it is a form of energy that travels in the form of waves, di ba? So kung energy yung light natin, that means they would follow one of the universal laws natin sa physics. Naalala niyo pa ba yung isa sa mga universal law natin sa physics? Okay, so 'di ba sa physics meron tayong tinatawag na law of conservation of mass and energy. So naalala niyo pa ba kung anong ini-state nitong law of conservation of mass and energy? So I think nandiyan to sa notes natin, no? Law of conservation of mass and energy states that your energy is neither created nor destroyed. Meaning, hindi mo pwedeng sabihin sa sarili mo na, uy, ang galing, nakakreate ako ng energy kasi energy is already around us. Ang energy nandiyan na siya sa paligid-ligid. Okay? So, hindi mo pwedeng sabihin nakakreate ka ng energy at hindi mo pwedeng sabihin nakasira ka ng energy. Okay, bakit? Kasi energy is already around us. Okay? So, therefore, ma'am, ano naman ngayon kung energy is neither created nor destroyed? Paano siya ginagamit? Paano natin ginagamit ngayon yung energy? Ang ginagawa lang natin sa energy, since energy is already around us, tinatransform, kino-convert lang natin sila from one form into another. In short, ano lang ang gusto sabihin sa atin ng law na yan? Ano bang gusto sabihin sa atin itong law of conservation of mass and energy? It simply states that your energy is convertible. As simple as that. Okay, energy is convertible. So, ma'am, totoo ba that energy is convertible? And since light is energy, can we say that light is convertible? Yes, lagyan natin ng example. Okay? Example ng manifestation that your light is definitely convertible. 'Di ba ang light natin, it is a form of energy that travels in the form of waves and knowing that convertible ang light natin. Okay, 'di ba ang light natin, in fact, convertible yan into electricity, 'di ba? Ang light energy, convertible yan into electrical energy. Ano yung best example ng mga device that can convert light energy into electrical energy? Best example nito yung mga solar panel natin, di ba? Okay, solar panel, they get light from the sun, convert it into electricity. Definitely, totoo ba na ang light ay convertible to other forms of energy? Yes. So best example, no, is yung ating solar panel, they convert light from the sun, convert it into electrical energy. Okay? Another good example, ang light natin, convertible yan into other forms of energy, particularly they're convertible into heat energy. Now, ano yung example ng idea na ang light ay convertible into heat energy? Okay, anong best example nito? Well, best example nito, una, is yung mga kulungan ng sisiw. Teka ma'am, ano meron sa kulungan ng sisiw? Napansin niyo ba yung mga kulungan ng sisiw may light bulb sila sa gitna? Now, what's the purpose of the light bulb? Bakit may light bulb sa gitna ng mga kulungan ng mga sisiw? Okay, yung mga chicks daw na. Okay, yung mga sisiw, 'di ba usually may light bulb sila in the middle? Why would they put light bulb in the middle? What's the purpose of the light bulb in the middle of the pen or middle of the kulungan ng mga sisiw? Ano bang purpose nun? Para lang ba hindi magkabungguan yung mga sisiw sa loob? Okay, para saan ba yung light bulb sa gitna? Actually, yung purpose ng light bulb na yon is to provide heat energy para mas mabilis lumaki yung mga sisiw. For faster metabolism, kailangan nila ng sufficient amount of light. Bakit? Kasi light can be converted into heat energy, which can give them faster metabolism. So therefore, totoo ba na ang light natin ay convertible into heat energy? Yes, definitely. Okay, so makikita natin yan, no, sa mga kulungan ng mga sisiw. Okay, sisiw na ginagawang 45 days na chicken. Pero parang hindi na yata 45 days ang chicken ngayon. Okay, napansin nyo ba sa mga fast food chains? Maliliit na, no, yung mga chicken. Okay, probably hindi na sila 45 days. Okay, pero either way, going back to the main issue. Okay, ano naman ngayon, ma'am? Ano naman ngayon kung light is convertible? Hindi naman kami mag-aalaga ng sisiw in the future, ma'am. Aanin namin yung information na yan. Okay, actually importante to. Particularly later on when we go to the parts of the spectrophotometer. Mamaya kasi may specific part yung spectrophotometer na sumusunod sa law of conservation of mass and energy. Etong part ng spectro na to kasi, ito yung nagko-convert ng light energy into electrical energy. And spoiler alert, sino nga pala yung part ng spectro na nagko-convert ng light into electrical energy? Madadaanan din naman natin to later on, pero that is actually your photo detector. Si photodetector pala yung part ng spektro na tumutulong mag-convert ng light energy into electrical energy. Okay, so wag kakalimutan, nagko-convert ng light into electrical energy, trabaho yan ng photodetector, and later on, pag-uusapan natin kung bakit. Bakit niya kailangan gawin yun? Bakit niya kailangang sumunod sa law of conservation of mass and energy? Bakit kailangan niyang i-convert yung light into electrical energy? Okay, pero for the meantime, huwag kakalimutan si photodetector. Siya yung part ng spectro that follows the law of conservation of mass and energy. They can convert light energy kasi into electrical energy. Okay, kaya importante 'tong mga 'to 'no, although parang feeling niyo hindi siya connected sa clinical chemistry, pero itong mga items na 'to magagamit natin later on to point out 'no, the important recall questions. Okay? Pero for the meantime, yan pala yung ibig sabihin ng law of conservation of mass and energy, and yan yung reason why we have to know that light is convertible to other forms of energy. Okay? However, sabi natin kapag photometry, we are measuring light. However, it sounds so simple, but it's not totally simple at all. Naging complicated ang pagme-measure ng light. Sobrang naging complicated ang measurement ng light because of two major reasons. Ano yung dalawang reason bakit daw naging sobrang complicated yung pagme-measure ng light natin? Dalawang reason. Una, ang dami kasing klase ng light. There are a lot of types of light. Number two reason, marami kang pwedeng gawin sa light. Naging complicated ang pagme-measure ng light kasi again, una, maraming klase ng light. Pangalawa, marami kang pwedeng gawin sa light. Unahin muna natin yung unang reason. Unang reason kung bakit light measurement has become complicated is because there are a lot of types daw of light. Okay, totoo ba na maraming klase ng light? Well, yes, maraming klase ng light. There are a lot of types of light. However, important thing is, ano yung tawag sa light na nakikita ng normal human eye? Okay, what do we call the light that is visible to a normal human eye? Okay, so wag kakalimutan, we would actually call that the visible light. Okay, so visible light is the light that is, as the name suggests, visible to the normal human eye. Ito yung light na nakikita natin. And recall question nga pala, ano yung range? Or pag sinabi nga palang range, spectrum. Ano daw pala yung range or spectrum ng tinatawag nating visible light? Okay, wag kakalimutan, ang visible light, according to the latest books, they would usually range between 400 to 700 nanometer. Ang kaya lang palang makita ng mata natin between 400 to 700 nanometers. That's why we call that the visible light. However, ingat kayo kasi sa mga lumang libro, which actually appeared on the board exam dati, walang 400 to 700. Okay, so nilagay natin sa chat box. Sa ibang libro kasi, lumang references particularly ang nakalagay pa ay 380 to 720 nanometers. Pero close enough naman, no? Close enough to 400 naman yung 380, yung 700 to the 720. So just in case na hindi nyo makita sa choices, yung 400 to 700, which actually happened previously on the board exam, choose the closest possible answer. Okay, and the closest possible answer is 380 to 720 nanometers. Okay, so wag kakalimutan, yan yung typical range ng visible light. Okay, ingat lang ha, pinapakita ko yung mga nasa lumang references kasi minsan, yung mga questions sa board exam minsan or some of them were derived from old references. So just in case na hindi nyo makita si 400 to 700, try choosing the closest possible answer. Okay? Pero either way, visible light daw pala is between 400 to 700 nanometer. Yan lang yung range na kayang makita ng normal human eye. However, laging tatandaan, normal human eye can only see the visible light, pero ingat, sa ibang libro kasi may other name yung visible light natin. Visible light is sometimes known also as the white light. Okay, ang original na appearance kasi ng visible light natin ay literally white. Okay, so white kasi ang appearance no ng visible light natin, kaya tinatawag din siya white light. However, pagdating sa fine arts at saka pagdating sa science, no, white is actually considered the most flexible na color. White is considered as the most flexible na color. Ma'am, paano mo nasabi na flexible etong white? Kasi sa white nakukuha yung iba pang mga kulay. From the white light, you can actually derive the other different colors that we see. Yung pink na nakikita natin, yung purple na nakikita natin, yung blue na nakikita natin, they were all actually derived from the white light. Ma'am, how sure are you na lahat ng kulay na nakikita namin, lahat yan ma'am galing sa white light? How sure are we that all the colors that we see were actually derived from the white light? Okay, ganito yan. Best example? Best example na lahat ng kulay na nakikita natin ay nasa white light. Best manifestation ito is on the rainbows. Okay? Ano nga ang sabi? Paano nga ba nagpo-form ang mga rainbows? Paano ba nagpo-form ang rainbow? Sabi nga sa kanta ng South Border, di ba? There's a rainbow always after the rain. So one of the prerequisites for you to be able to form rainbow ay kailangan mo ng ulan. Okay, kailangan mo ng tubig ulan. And syempre, kailangan mo ng white light coming from the sun. Okay, so kunwari, ito yung ating sun. Naglabas siya ng white light and the white light passes through the raindrop. The raindrop acts as a prism. Prism dividing the white light into the 7 different colors, thus creating the rainbow. Okay, children, what are the 7 different colors of the rainbow? Okay, 7 different colors of the rainbow. Syempre, we have the acronym Roy G. Beef. Okay, so Roy G. Beef, we have red, orange, yellow, green, blue, indigo, and violet. Okay, so those are the 7 different colors of the rainbow that would appear kapag yung white light natin ay nag-pass through no, dun sa ating prism. So in here, we have the acronym Roy G. Beef, the 7 different colors of the rainbow. Uy, teka ma'am, bakit yung Roy G. Beef mo ma'am baliktad? Bakit yung Roy G. Beef natin naka-reverse? order. Kasi laging tatandaan, Roy G. Biv in reverse order is actually their arrangement from 400 to 700 nanometers. Okay, yung pala yung magic trick dun, no? Yung Roy G. Biv pala, in the reverse no order, that is their arrangement from 400 up to 700 nanometers. So, ibig sabihin, sino pala yung matatagpuan natin sa bandang 400 nanometers? That is where you would find the violet na color. Sino naman yung kulay na nasa bandang 700 nanometers? This would actually be connected to the red na color. Which now brings us to two important recall questions. Recall question, sino pala yung color with the highest energy? Sino daw pala yung color with the highest energy? Now, ingat ha, ingat. Kasi anong sabi natin sa connection ng light at saka nung ating energy, nung wavelength ng light natin at saka energy, they are inversely proportional. So therefore, if you're looking for the color with the highest energy, it should be the one with the shortest wavelength. Eh, sino ba yung may shortest na wavelength? Nasa bandang 400 yung shortest. Yes, it would be the violet na color. So, laging tatandaan, violet pala yung may pinakamataas na energy kasi remember, anong relationship ng wavelength to the amount of the energy? They are inversely proportional. So, if you're looking for the one with the highest energy, look for the one with the lowest, the shortest na wavelength. And dun sa visible spectrum natin, it just so happens that violet is the one with the shortest na wavelength. So that is contradictory to what we usually think of, no? Usually kasi feeling natin si red yung malakas, si red yung strong, si red yung nag-aapoy at naglalagablab. Pero in reality, mababa pala yung energy ng red natin. Si violet pala yung may pinakamataas na energy. So therefore, ingat kayo ha. Recall question yan. The color of the rainbow with the highest energy is the color with the shortest wavelength, and that is in fact your violet. Okay? However, isa pang recall question is yung color naman ng rainbow natin with the longest wavelength. So, syempre, kapag longest wavelength, sino pipiliin natin? It would now be the red na color. Okay, so red would now have the longest wavelength kasi remember, ang red natin ay nasa bandang 700 nanometers. Okay, so therefore, ingat kayo sa question ha. Recall question kasi yung may highest energy and that would be the violet. Pero recall question din kasi yung merong longest wavelength. And that will be the red na color. So therefore, wag niyong kakalimutan that energy at saka si wavelength, opposite sila of each other. They are, again, inversely proportional to each other. Okay? So therefore, yan yung 7 different colors of the rainbow at makikita natin yan, galing yan sa white light natin. And again, white light is what you would call the visible light. Okay? However, sabi natin visible light, ito kasi yung light na nakikita ng normal human eye. So, teka, kung may light na nakikita ng normal human eye, that means may baliktad, ano? Merong hindi nakikita. Anong tawag natin sa hindi nakikita ng normal human eye? So, syempre, we would call it invisible light. And usually, anong meron sa invisible light natin? Well, actually, invisible na, no? Invisible na anything that is outside. Anything that is outside the visible na light will be totally invisible na to the normal human eye. In short, anything that is less than 400 is invisible na to the normal human eye. And on the opposite side, anything that is higher than 700 would also be invisible to the normal human eye. Kasi remember, ang normal human eye, ang nakikita lang ay between 400 to 700. Anything outside of that, syempre would be called invisible light. Okay? Uy, invisible na daw pala yung less than 400, invisible na daw pala yung 700 or more than 700 nanometer to a normal human eye. However, disclaimer lang, animals. Some animals can see light that is outside the human capacity. May mga animals pala no, na yung mata nila are designed in such a way that they can see light that is outside the normal human capacity. Best example, una, mga ibon. May mga members tayo ng avian species no, that can see light that is outside the visible na spectrum. However, the best example natin, aside from members of the avian species or mga birds, isa pang perfect example no, ng animals that can see light that is outside the human capacity will be cats. Cats. Napansin niyo kakaiba yung mata ng mga pusa, okey? Parang, glow in the dark 'no, yung mata ng mga pusa. Yung mata kasi ng mga pusa, they are actually designed in such a way that they can see light that is outside the normal human capacity. Okey, actually may mga humans din naman daw that can see light that is outside the normal capacity natin. However, kino-correlate na nila 'to sa paranormal activity. Usually they would correlate it 'no, to paranormal activity. Particularly, ito yung mga tinutukoy nating mga taong may third eye. Yung mga tao daw na may third eye, scientifically speaking 'no, they can see light that is outside the normal human capacity. So yung nakikita daw palang light ng mga taong may third eye are actually light that is outside the normal human capacity. And that is now precisely the reason why napapansin niyo ba kapag mga horror movies, kapag mga suspense movies, kadalasan sinong animal ang ginagamit nila? Kadalasan they're using cats, ano? Why? Kasi cats can see light that is outside the normal human capacity, and usually light that is outside the normal human capacity are correlated to paranormal activity, paranormal activity. Kaya 'pag mga horror movies 'no, kadalasan they use the cats, they use cats. And actually this could be ano, quite scary 'no, kaya lesson for the day, ingat sa pakikipag eye to eye contact with the cat. Kasi if a cat is staring at you, they are probably not looking at you. Okay, probably hindi sila nakatingin sa'yo. Probably they're seeing something else. They're seeing something beside you or something behind you. Yung mga gano'ng moment. Okay, kaya ingat sa pakikipag eye to eye contact with the cat. Mataas ang chance na hindi sila sa'yo nakatingin. Okay, probably may nakikita silang something else. Okay? However, by the way, since meron kaming 11 cats at home, okay, we actually have 11 cats at home. Most of them are rescue cats, okey, mga in-adopt lang namin 'no, ng mga stray. Okey, kaya yung ano, kaya nagtatrabaho talaga ako para sa 11 naming pusa. Meron kaming 11 pusa at saka isang aso. Yung aso namin, may identity crisis na ata, hindi niya na alam kung aso pa ba siya or pusa. Pusa na siya. Kasi ang kinakain niya na ay cat food. So, siyempre since maraming pusa, eh, puro cat food yung binibili namin, eh, wala kaming pang dog food kumbaga. Kaya ang kinakain niya na rin, eh, pang-pusa, okey. Kaya technically parang may identity crisis na yung aso namin. Ma'am, paano mo nasabing may identity crisis na siya? Kasi hindi siya tumatahol. Yung aso namin hindi na siya tumatahol. Okey, nangangalmot siya actually, okey, weird nung aso namin. Pero either way, since ang mga kasama niya ay puro pusa, okey, technically parang feeling ko nagiging pusa na rin siya. Going back to the main, topic, nung time ko or there was a time dati 'no, nung dumating ako sa bahay 'no, okey, yung mga pusa namin lahat sila ha, 11, nakatitig sila sa isang corner nung bahay namin. So, siyempre natakot ako. Lahat sila, eh, 11 ba naman 'no, nakatingin dun sa isang corner. Sabi ko, "Ano ba nakikita nila dun sa corner na yun ng bahay namin? Bakit lahat sila nakatingin on that area?" Okay, probably they're seeing something, a light that is invisible 'no, to a normal human eye. Okay, pero either way, ang creepy lang kasi 11 sila, eh, lahat sila nakatingin dun sa isang area. Wala namang ipis, wala namang butiki, wala namang anything moving in there, but they're just all staring at the same spot. So, probably they're seeing something 'no, that is outside the normal human capacity. Pero lesson for the day, wag makikipag-prolonged eye-to-eye contact with the cats kasi mataas ang chance that they're not really looking at you. Pero either way, bago tayo mauwi sa paranormal activity, balikan muna natin itong related sa pagiging medtech natin. So dito, anong tawag natin sa light that is less than 400 nanometers? What do we call the light that is immediately less than 400 nanometers? Uy, less than 400 nanometers? Di ba nasa 400 si violet? Uy, less than 400, meaning shorter than the violet. So what do we call the light that is shorter than 400? Shorter than the violet, we will actually call it, yes, the ultraviolet. So from the word ultraviolet, ba't pala siya tinawag the ultraviolet? Kasi it's literally shorter. Shorter than the violet. And to be more specific, recall question, yung range ng ultraviolet light natin. Okay, ano daw pala ang range ng ultraviolet light natin? Ang ultraviolet light, recall question yung range, according to the book of Kaplan, it is somewhere between 4 to 400 nanometers. So, ang ultraviolet light daw pala natin no, is somewhere between 4 to 400 nanometers. Okay, recall question yung range ha. Range ng visible light was a recall question. range ng ultraviolet light was also a previous na recall question. Pero disclaimer lang ha, meron pang mas maiksi pa sa ultraviolet. Shorter than the ultraviolet ay ang mga X-rays. And shorter than the X-rays will be the gamma rays. Pero syempre, hindi na to kasama sa buhay natin as medtech. No? Iwan nyo na to sa mga radtech. Okay, sina radtech na ang bahala sa X-rays at saka gamma rays. Hindi na to sakop ha ng medtech field. Ang kailangan lang natin sa laboratory ay si visible at etong si ultraviolet. So hindi nasakop ng field natin ha, yung mga X-rays at saka gamma rays. Okay, pero for now, wag kakalimutan na ang ultraviolet light is somewhere between 4 to 400 nanometers. Okay? So yan yung lower end ng spectrum natin. But what about the upper end? Ano naman tawag natin dun sa light that is beyond 700 nanometers? Greater than 700 nanometers. E teka, sino na nga ba yun nasa 700 nanometers? Si red. Si red ay nasa 700. So, bigger than 700, meaning bigger than the red color. So, what do we call the light that is bigger than the red? We would now call it your infrared. Okay, doon pala galing yung word no na ultraviolet at saka infrared. Ultraviolet kasi it's literally shorter than the violet. Shorter than violet. Infrared kasi it's literally bigger than the red. Okay, so bigger than the red, we have the infrared. Okay? And to be more specific, although hindi pa naman to naging recall question, pero malay natin, baka siya naman ang lumabas this time. Ano daw pala ang range ng infrared natin? Again, according to the Book of Kaplan, ang infrared naman natin is between 700 nanometers up to 0.3 centimeters. Okay, so biruin mo, pwede siyang umabot ng up to 0.3 centimeters. Okay, ang infrared natin is somewhere between 700 nanometers up to 0.3 centimeters. Okay, pero so far, when it comes to wavelength, ang nag-appear na previously is itong 400 to 700 nanometers at itong 4 to 400 nanometers natin. Pero syempre, disclaimer lang, meron pang mas malaki sa infrared ha. Bigger than the infrared ay ang mga microwaves. Bigger than the microwaves will be the radio waves. Pero syempre, hindi na to sakop ng medtech ha. Hindi na natin sasakupin yung microwave and radio wave na yan. Pabayaan nyo na ang mga engineers sa microwave at saka sa radio wave. Hindi na yan sakop ng field natin as med text. So technically speaking, ano lang kailangan natin ma'am sa laboratory? Well, tatlong spectra or tatlong range lang ng light ang kailangan natin ha. We will only be needing the visible light, which is again 400 to 700 nanometers. We will also be needing the ultraviolet light, which is between 4 to 400 nanometers. And syempre yung ating infrared, which is again somewhere between 700 nanometers up to 0.3 centimeters. Ito ngayon yung reason kung bakit nabuo yung word na spectrophotometry. Di ba kanina ang na-describe lang natin ay photometry? We were just measuring light. However, hindi pala advisable kung ordinaryong photometry lang. Bakit? Kasi kung simpleng measurement lang ng light ang gagawin mo, aba maliligaw ka ng landas. Bakit maliligaw ng landas? Kasi ang daming klase ng light. Kaya maganda yung word na spectrophotometry. Bakit? Kasi nagme-measure ka ng light on a certain spectrum or again, pag sinabing spectrum, range. And again, ano yung tatlong spectra or ranges ng light na ginagamit natin? Visible, ultraviolet, and infrared. Okay? Kasi kapag simpleng photometry lang ginawa mo, maliligaw ka ng landas. Ang daming klase ng light to. Hindi maganda kung photometry lang ang gagawin mo kasi maliligaw ka ng landas dahil maraming klase ng light. Okay? Now, ang tanong is, importante ba talagang i-specify, ma'am, yung spectrum? Do we really need to specify the spectrum of the light natin? Kailangan ba talagang i-specify, ma'am, kung ultraviolet, kung visible, or kung infrared? Yes, kasi laging tatandaan, ang first part kasi ng spektro ay light source. Maraming klase ng light source. Depende sa light range na kaya nilang ilabas. Okay? Different types of light sources would vary depending on the range of light na kaya nilang ilabas. Meron tayong tatlong klase ng light sources ha. May mga light sources tayo na nakakapaglabas ng visible light, may mga light sources tayo na nakakapaglabas ng infrared, meron tayong mga light sources na nakakapaglabas ng ultraviolet. na light. Kaya mahalaga na i-specify yung wavelength. Mahalaga na i-specify yung spectrum. Kasi magkakaibang analyte, laging tatandaan, magkakaibang analytes would have different wavelength. Okay, they would need different wavelength. And syempre, kung magkakaibang wavelength ang kailangan niyan, ibig sabihin they would need different na light sources. Magkakaibang analyte, magkakaibang wavelength. Kung magkakaibang wavelength yan, that means magkakaibang light sources ang kailangan natin. Okay? Totoo ba ma'am na kailangan nating i-specify yung wavelength? Okay, kailangan ba talaga na malaman natin kung anong spectrum ang gagamitin natin? Yes, magkakaibang analyte ha, magkakaibang wavelength. Kung magkakaibang wavelength, edi magkakaibang spectrum, magkakaibang light source ang gagamitin natin. Okay, para madali, lagyan natin ng example. Example number 1, nandyan sa notes natin, yung mga wavelengths natin. And yung mga nilagay natin dyan sa notes, mga recall question yan. So therefore, dapat ngayon pa lang, nagme-memorize na kayo ng mga wavelengths. Kasi kakailanganin yan pagdating sa board exam. Recall question number 1 has something to do with the alin? Has something to do with your Caraway method. Okay, so Caraway method. Unang tanong nga pala sa Caraway method, no? Para saan nga pala si Caraway method? Okay, Caraway method is actually a method for your uric acid. This is one of the oldest method natin for uric acid. Pero I think hindi nyo na siya maririnig as Caraway method nowadays, no? Ang tawag na kasi sa kanya ngayon ay phosphatungstic acid method. Siya na yung tinatawag na phosphatungstic acid method. Pero ingat, kasi sa mga lumang libro, ang tawag pa sa kanya ay Caraway method. Pero again, nowadays, we call it the phosphatungstic acid na method. Okay, phosphatungstic acid kasi yung main reagent niya. And speaking of which, recall question number 1 sa Caraway method is kung para saan siya ha. It is one of the oldest methods natin for uric acid. However, pangalawang recall question yung positive result. Ano nga pala yung positive result na inaabangan natin sa Caraway method? Usually, ang inaabangan natin dyan ay yung appearance ng tungsten blue, which can be measured spectrophotometrically. And pangatlong recall question, wavelength. At what wavelength daw pala do we measure the tungsten blue? Anong wavelength daw pala ang ginagamit natin pag magme-measure tayo ng tungsten blue? Laging tatandaan sa lumang libro, at ito yung nag-appear dati ng board exam, range yung nakalagay sa lumang libro. Ang tungsten blue can be measured somewhere between 650 to 700 nanometers. Okay, 650 up to 700 nanometers. Okay, so dyan daw mini-measure si tungsten blue. However, what if ma'am, we are asked to choose one? What if we are asked to choose a specific na wavelength? So just in case papiliin kayo, sa mga bagong libro kasi ang nakalagay na ay 660 nanometers. So just in case na papiliin kayo ng isang specific wavelength, kindly choose 660 nanometers. Pero nung time na nag-appear to ng board exam, ang nasa choices is ito. 650 to 700 nanometers taken from the book, the old references yan particularly. So just in case lang napapiliin kayo ng single na number, make sure to choose 660 nanometers. And kung 660 yan, anong light source kaya ang gagamitin natin? O yung i-measure mo, 660, saan ba pasok yung 660 na yan? 660 is within the visible na range. So therefore, kung magpe-perform ka ng Caraway method, ano dapat ang light source na gagamitin mo? You need a light source na naglalabas ng visible na light. Kasi yung i-measure mo ay 660. 660 is within the visible na spectrum. So yun pala yung reason kung bakit importante na nagme-memorize tayo ng wavelength, no? Again, different analytes kasi would make use of different wavelengths. Different wavelengths would require different light sources. Like in this case, mini-measure natin si tungsten blue. So ang wavelength na kailangan mo ay 660 nanometers. And syempre, kung 660 yan, anong light source ang kailangan natin? Visible na light source. Dapat yung nasa spectrophotometer mo if you are planning to do the Caraway. Okay, so yun yung importance, no? Yun pala yung reason kung bakit kailangan nakaspecify yung spectrum. Kailangan nakaspecify yung range. Magkakaibang analyte, magkakaibang wavelength, magkakaibang light source ang gagamitin natin. Okay? Let's try another example and also another recall question. Sabi natin, lumang method na si Caraway method. Nowadays kasi, ang ginagamit na natin sa mga automated instrument natin ay enzymatic na method. And usually, ano yung enzymatic method natin? For the uric acid analysis. Usually, ang enzymatic method natin for uric acid, ito yung gumagamit ng uricase. Okay, uricase yung enzyme reagent na ginagamit natin sa makabagong method natin no, for the uric acid. Okay? And dito, ang purpose ng uric case is to convert your uric acid into allantoin. Okay? Pero actually, ang measure mo rito is yung uric acid before and after. And usually, at what wavelength do we measure the uric acid? Laging tatandaan, si uric acid, this is measured at 293 nanometers. Actually, sa ibang libro, ang nakalagay ay 290. Sa ibang libro, 293. So, the typical range is 290 up to 293 nanometers. Pero, nung nag-appear kasi ito ng board exam, ang nasa choices was 293. Okay, so just in case, 293, ito yung pwede nyo makita sa choices or dati nang nakita sa mga choices, 293. Pero again, sa ibang libro kasi, ang nakalagay ay 290. So 290 to 293 nanometers, pero when this appeared in the board exam dati, 293 yung nakita sa choices. Pero either way, mapa 290 or 293 man, anong light source ang gagamitin natin for this? 290, 293, saan pasok yan? Pasok yan sa ultraviolet na range. Remember, ang ultraviolet natin is somewhere between 4 to 400 nanometer. Nasa loob niyan yung 293 natin. So therefore, if you're planning to do an enzymatic method for your uric acid, anong light source pala ang kailangan natin? Ultraviolet. Now, teka ma'am, bakit ganon? Parehas naman silang pang uric acid pero bakit magkaiba yung wavelength nila ma'am? Parehas lang naman silang pang uric acid ma'am. So, enzymatic method, Caraway method, they're both methods for uric acid. Bakit magkaiba sila ng wavelength ma'am? Okay, kasi ganito yan ha. Sa Caraway method kasi, hindi naman si uric acid ang mismong mini-measure natin. Ang mini-measure mo rito ay si tungsten blue. Kaya ang wavelength na kailangan mo ay 660 nanometer. So si Caraway method ha, measures the tungsten blue. Phoebe is tungsten blue. Tungsten blue, kaya ang wavelength na ginagamit natin ay 660 nanometers. However, dun sa enzymatic method natin, hindi naman si tungsten blue ang mini-measure mo eh. Ang mini-measure mo na ay mismong uric acid. Kaya iba yung wavelength na ginagamit sa kanya. 293 nanometers. So although again, parehas silang method for uric acid, pero magkaibang wavelength ang ginagamit nila kasi magkaiba yung mismong mini-measure. Ang mismong mini-measure kasi sa Caraway method ay si tungsten blue, kaya 660 nanometers ang gamit natin. Okay, pero kapag mismong uric acid ang mini-measure mo, you will have to use 293. Okay, so ingat lang ha, parehas kasi silang method for uric acid, pero despite that, magkaibang wavelengths ang ginagamit. Okay? Pero bottom line, kapag enzymatic method for uric acid analysis, no, you will have to use a different light source. Ang light source mo rito will be the ultraviolet. Okay? So that would be another good example no of as to why we have to specify the wavelength. Kailangan nagme-memorize tayo ng wavelength kasi una, tinatanong sila sa board exam. Pangalawa, kapag alam mo yung wavelength, alam mo kung anong light source ang gagamitin mo. Kasi again, may mga spektro tayo na ang nakalagay visible lang na light source, yung iba naman ultraviolet na light source, yung iba infrared yung light source. Okay? Another recall question concerning the wavelength. So, meron na tayong dalawang recall question sa wavelength, no? Wavelength ng sa tungsten blue, 650 to 700 nanometers. Wavelength ng sa uric acid, 293 nanometers. Third recall question. Another favorite na recall question. Next to the enzymatic method for your uric acid, recall question, si Dubowski. Uy, Dubowski, may tatlong recall question yan. Ano yung dapat tandaan sa Dubowski natin? Yung word na Dubowski, hindi nyo na ito makikita sa mga bagong libro. Yung Dubowski na word na yan, makikita nyo yan sa lumang libro, Albas. You can find this word in the book of Albas. And nowadays, hindi na siya tinatawag na Dubowski. Kadalasan ang tawag na sa kanya ay condensation. method, or probably baka mas familiar kayo dun sa isa pa niyang pangalan. Yung isa pa kasi niyang pangalan ay orthotoluidine na method. Kasi ang reagent ay si orthotoluidine. Okay, so iyan yung iba-iba niyang pangalan ha. Sa mga super duper lumang libro kasi, Dubowski pa yung tawag sa kanya. Sa bagong libro, condensation. Sa ibang libro, orthotoluidine method. Kasi orthotoluidine yung kanyang main reagent. However, recall question number 1, no, is kumpara saan? Si Dubowski. Dubowski is an old method for glucose analysis. Pangalawang recall question, yung kanyang positive na color. Ano daw pala yung positive na color natin sa Dubowski? Okay, positive color is the formation of the bluish green color, which leads us to the third recall question. Third recall question, wavelength. At what wavelength do we measure the bluish green na color? Okay, we usually measure it between 620 to 630 nanometers. Pero dati nung time ng board exam, 630 yung nag-appear no, sa choices. Okay, so 620 to 630 nanometers, pero dati ng board exam, ang nag-appear sa choices ay 630 nanometers. So teka, kung 630 nanometers yan, anong light source ngayon ang kailangan natin? 620 to 630, pasok pa yan sa visible na spectrum. So therefore, you will have to use visible light source for them. Okay? So therefore, yan yung characteristics ng Dubowski reaction natin. Again, tatlong recall question yan ha. Dubowski ay para sa glucose, bluish green yung positive result. And don't forget the wavelength, 620 to 630 nanometers. However, yung pangalawang recall question is a bit controversial. Kasi dati, nung tinanong yan ng board exam, no, ganito yung pagkakatanong sa kanya. Positive result in the condensation method. Okay, positive result daw in the condensation method, and ito yung mga choices. Letter A, red. Letter B, yellow. Letter C, blue. Letter D, green. Hala, di ba bluish green yung positive result? Now you're torn between two lovers. Now you're torn between blue and green. Now, sino sa tingin nyo ang mas magandang piliin? Mas maganda kayang piliin si blue or mas maganda kayang piliin si green? Bluish green kasi eh. Tapos ayan, naipit ka between blue and green. Okay, sino pipiliin mo? Si blue ba or si green? Sino sa tingin nyo ang mas matimba sa kanilang dalawa? Nangyari yan dati sa board exam ha, pinapili between blue and green. Sino sa tingin nyo mas maganda? Piliin? So the answer is yes, letter D, green. Okay, green yung mas magandang piliin. Ma'am, bakit? Bakit mo in-eliminate yung answer ko, ma'am? Bakit mo in-eliminate yung answer ko? Yung iba red na lang daw, no? Para wala ng problema. Para hindi ka na mamimili. Iba na lang ang piliin mo, no? Instead na blue or green. Ma'am, bakit green? Dalawang reason. Una, sa lumang libro kasi, green lang ang nakalagay. Sa mga bagong libro kasi, bluish-green yung nakalagay. Pero if you were to consult the old references, green lang ang nakalagay. Pangalawang reason, connected sa grammar. Ano ba kasing ibig sabihin ng bluish-green when it comes to grammar? Bluish-green, no? Green yung tunay niyang kulay. Bluish kasi rito is just like an adjective that describes the green. So pag sinabing bluish-green, green siya na may konting blue, parang ganon. Green siya na may konting blue. So iba pala ang bluish-green sa greenish blue. Okay, ano palang ibig sabihin naman ng greenish blue? Pag sinabing greenish blue, blue naman siya na may konting green. Parang ganon. Okay? So technically speaking, yung original niyang kulay is green. Yung bluish kasi is just like an adjective that describes the green color. Furthermore, again ha, sa lumang libro kasi ang nakalagay lang ay green. Which goes to show no na yung mga Board of Examiners, sometimes they're still using the old references. Minsan gumagamit pa rin sila ng mga lumang libro as references. Kaya kailangan familiar tayo sa mga ganyang information. So again ha, just in case papiliin kayo between blue and green, kindly choose the green color. Okay, kasi green yung nakalagay sa mga lumang references. Okay? Pero all in all, yan yung tatlong recall questions sa Dubowski ha. Minsan they would just ask you kung para saan si Dubowski, para yan sa glucose analysis. Pangalawa, don't forget the positive color. Green would be the positive na color. And pangatlo, yung wavelength ha. Particularly yung nag-appear dati ng board exam ay 630 nanometers. Okay, so those are the three important matters concerning the Dubowski natin. One of the oldest method natin for the glucose analysis. Okay? However, another recall question pagdating sa wavelength, no, ay yung method naman natin for LDH. LDH, familiar pa ba kayo dun sa dalawang method natin for LDH? Kung natatandaan nyo pa sa mga lumang libro nyo lang din to makikita, meron tayong tinatawag na Walker method at saka Wroblewski-Ledoux. Okay, Ledoux daw yung basa dyan. Okay, pero either way, don't worry, wala namang oral exam si MedTech board exam, no? Kaya whichever way you want to pronounce it. Pero ano nga bang meron sa Walker method at saka sa Wroblewski-Ledoux? Naalala nyo pa ba yung difference between the Walker method and the Wroblewski-Ledoux? Si Walker method, siya yung forward method natin. The forward reaction for LDH. Okay, ano nga ba ibig sabihin pag sinabing forward? Pag sinabing forward, you are converting lactate into pyruvate. Okay, so lactate to pyruvate, yan yung tinatawag nating forward na method. Okay? Si Wroblewski-Ledoux naman, siya naman yung reverse reaction natin for LDH. By the way, ingat kayo dyan sa forward at saka sa reverse na yan ha. Kasi may forward and reverse din yung CK natin. So ingat ha, si Walker at saka si Wroblewski, forward and reverse na reaction yan for the lactate dehydrogenase. And pag sinabing reverse, anong ibig sabihin nun? Babaliktarin mo lang, pyruvate papuntang lactate. Okay, so if you're converting pyruvate into lactate, we would call that the reverse reaction. And the method for that is what we call the Wroblewski-Ledoux. By the way, kaya ako nilagay yung reaction kasi there was a time in the board exam na binigay yung reaction. Tapos tatanungin kayo, anong pangalan ng method na to? Anong pangalan ng method na to? So mag-iingat kayo ha. Okay, kasi minsan nakalagay lactate to pyruvate and they would ask you what's the name of the method. Okay? So Walker, forward, lactate to pyruvate. Wroblewski-Ledoux, reverse, pyruvate to lactate. And ingat kayo kasi may forward at saka reverse din ang CK natin. Okay? Insert na natin kasi madalas magkakasama sa choices to. Meron tayong forward reaction for the CK or creatine kinase. We call it the Tanzer-Gilvarg na method. And pag sinabing Tanzer-Gilvarg, forward reaction yan, ang kino-convert mo naman dito ay si creatine into creatine phosphate. Okay, yan yung forward reaction natin. Pero syempre, kung may forward, meron tayong reverse. Sino naman daw yung reverse natin? Si Oliver Rosalki. Okay, Oliver Rosalki naman is the reverse reaction para sa anong enzyme? Ingat kayo ha, pang CK yan. Reverse reaction for the CK, we have the Oliver Rosalki. Okay, so Oliver Rosalki, and syempre, pag sinabing reverse, pabaliktarin mo lang. Creatine phosphate, pabalik into creatine. So ingat kayo kasi pag tinatanong yan, magkakasama sila sa choices. They would give you the enzymatic equation and they would ask you what's the name of the method. Okay, at madalas magkakasama sa choices yung apat na yan, si Walker, si Wroblewski, si Tanzer-Gilvarg, at saka si Oliver Rosalki. So try to be careful now with those names particularly. Okay? Kasi again, minsan hindi kayo sa question maguguluhan minsan sa choices kayo maguguluhan. Okay? Pero either way, si Walker at saka si Wroblewski, parehas silang method for LDH. And usually kapag LDH, ano ba talaga yung minimeasure natin? We're not really measuring the actual LDH, no? Ang minimeasure natin dito actually is the formation of either the NAD or the NADH. Laging tatandaan, kapag ang apelido ng enzyme mo ay dehydrogenase, asahan mo na ang i-measure mo dyan is NAD or NADH. And usually at what wavelength do we measure the NAD or the NADH? Recall question yung wavelength ha. Pag nagme-measure ng NAD, NADH, we usually measure it at 340 nanometers. So again ha, pag ang apelido ng enzyme mo ay dehydrogenase, makikita din natin yan later on when we go to carbohydrates. Pagpunta natin sa G6PD, dehydrogenase din kasi si G6PD, di ba? Okay, ang minimeasure din doon ay connected sa NAD, NADH. And again, at what wavelength do we measure the NAD, NADH? We measure it at 340 nanometers. Uy, 340 nanometers, meaning anong light source ang kailangan natin? We will need to use an ultraviolet na light source. So ultraviolet na light source if you're planning to do the LDH methods natin for analysis. So, ganyan ka-importante, no? Ganyan ka-importante yung pag-i-specify ng wavelength. We need to specify the wavelength kasi different analytes would utilize different wavelengths. And since magkakaibang wavelength yan, magkakaibang light source ang gagamitin natin sa kanila. Okay? So these are some of the methods sa clinical chemistry that requires us to memorize the wavelength of the light. However, ingat kayo kasi hindi lang tayo sa clean chem nagme-memorize ng wavelength, may mga wavelength din tayo na recall questions sa ibang subjects. Best example, recall question sa hematology is yung wavelength for the cyan-met hemoglobin. Uy, cyan-met hemoglobin. Cyan-met hemoglobin, di ba kapag shortcut natin yon, we usually write it down as HICN. Cyan-met hemoglobin. And recall question nga pala, at what wavelength nga pala do we measure the cyan-met hemoglobin? HICN or cyan-met hemoglobin can be measured spectrophotometrically. Usually they are measured at 540 nanometers. And for that, anong klaseng light source pala ang kailangan natin? We will be needing a visible na light source. Okay, visible na light source kasi 540, pasok pa sa visible na spectrum yan. Okay, so therefore, ina-apply din pala yung mga wavelength na yan ha, hindi lang sa clinical chemistry, ginagamit din yan sa iba pang departments ng laboratory. Best example yung nasa hematology, cyan-met hemoglobin natin na gumagamit ng 540 nanometers, and for that, you will need a visible light source. Okay? Another good example ng wavelength na kailangan nating i-memorize outside the clinical chemistry department, connected naman sa AUBF. OD 450. Optical density. OD stands for optical density. Optical density at 540. 450 rather. 450 nanometer. Okay. OD, optical density, at 450 nanometers. Uy, teka, sino daw yung substance na mine-measure natin, particularly sa amniotic fluid, na may absorbance at 450 nanometers, or ang optical density niya daw is at 450 nanometers? Laging tatandaan, sa OD 450, we are measuring bilirubin in the amniotic fluid. We measure bilirubin in the amniotic fluid at 450 nanometers. Uy, 450 nanometers, meaning anong light source ang kailangan mo dyan? Kailangan mo ng visible na light source. Okay, 450, pasok pa dun sa visible spectrum natin. Therefore, if you will be performing the OD 450 sa amniotic fluid, you need to use a spectrophotometer na nakakapaglabas ng visible na light. And by the way, ba't nga pala tayo nagme-measure ng bilirubin sa amniotic fluid? Why do we measure bilirubin in the amniotic fluid? Ano nga palang purpose ng OD 450? Ginagamit yan, no, to assess. Ginagamit yan to assess the severity of the HDN or the hemolytic disease of the newborn. Okay, nowadays, ang tawag na sa kanya ay HDFN, hemolytic disease of the fetus and of the newborn. Kasi hindi lang naman newborn siya ang nagsasuffer from HDM. Even fetus na nasa loob pa ng tiyan ni mommy, pwede silang mag-suffer from HDFN. Okay, kaya nowadays, they call it the hemolytic disease of the fetus and newborn. We call them the HDFN, or in short, siya rin naman yung HDN dati. Pero to be more specific, hindi lang nangyayari yan sa newborns, kahit sa fetus pwede mangyari ang HDN. So para daw pala malaman kung gaano kalala yung HDN, uy dito ha, ginagamit siya para malaman kung gaano ka-severe. Meaning, alam na ni doctor na may HDN. Alam na ni doctor na may HDN, the doctor just wants to know gaano kagrabe. Gaano kagrabe yung HDN. Ma'am, bakit kailangan malaman ni doctor kung gaano kagrabe yung HDN? Bakit kailangan malaman ni doctor kung gaano ka-severe yung HDN? Ano nga palang reason why they have to do that? Kasi yung next move ni doctor, yung gagawin niyang intervention kasi depends on how severe the hemolysis is. Yung susunod na gagawin ni doctor, depende sa result ng OD 450. Kasi gaano ba kagrabe yan? Kailangan bang masalina na ng dugo si baby? Kailangan ba na ganito na yung gawin kay baby? Okay, so technically, yung susunod na gagawin ni doctor, depende yan kung gaano kalala yung HD Yan. Pero either ways, HDN, pag-uusapan na lang natin yan when we go to ISBB kasi parang ako yata makasama nyo sa ISBB na discussion, okay, on the future discussions natin. So, saka na natin pag-uusapan si HDN when we go through ISBB. Okay, pero for the meantime, yan pala yung purpose ng OD450, no? Ginagamit yan para malaman kung gaano kagrabe ang hemolysis na nangyayari sa mga babies na may HDFN. Okay? However, ingat kayo kasi may katunog si OD450 connected pa rin sa amniotic fluid na mag-iingat kayo. Iba yung OD450 sa OD650. This time, ano naman ang minimeasure natin sa 650? Sino naman daw yung minimeasure natin sa OD650? OD650, ingat kayo ha, iba yan sa OD450. Sa OD650, ang ginagawa natin ay ang tinatawag na lamellar body count. Ma'am, bakit nagbibilang tayo ng lamellar bodies? Para saan ba yan si lamellar body? Kung ang OD450 ay para sa HDM, yung OD650 naman ay para sa FLM. Ano nga palang meaning ng FLM? FLM stands for fetal lung maturity. Okay, so laging tatandaan, fetal lung maturity pala, no, para sa fetal lung maturity, COD 650. Ano ba yung fetal lung maturity? As the name suggests, gusto mo lang malaman kung mature na ba yung lungs ni baby. Fetal lung maturity. The doctor wants to know, mature na ba yung lungs ni baby? Teka ma'am, ba't kailangan malaman? Why do we need to know kung mature na ba ang lungs ni baby? Why do we need to know? Bakit kailangan pa nating pagkaabalahang malaman kung mature na ba yung lungs ni baby? Well, actually, importante to especially sa mga premature na babies. Premature na baby. Di ba pag sinabing premature na baby, ito yung mga baby na literally kulang sa buwan. Okay, sila daw yung mga baby na kulang sa buwan. At sabi ng matatanda, no, kapag kulang sa buwan, topakin daw. Okay, so, di ba, I'm not sure kung narinig nyo pa to, pero madalas ko narinig to sa aking mga grandparents, no. Sabi nila, ay, naku, intindihin mo na lang yan kasi kulang yan sa buwan, kaya yan topakin. Have you ever heard of that? Okay, pero ingat nga pala ha, hindi lahat ng kulang sa buwan ay topakin. Huwag kayo masyadong judgmental. At hindi lahat ng topakin ay kulang sa buwan. Okay, ginagamit lang nilang statement yun, no? Pero hindi naman talaga totoo yun, no? Okay, pero either way, may mga babies na premature, kailangan na kasi silang ilabas kahit kulang sa buwan, kailangan na sila agad ilabas for the safety of the baby and of the mommy. Para daw maging ligtas si baby at saka si mommy, minsan kailangan nang ilabas si baby prematurely. Pero hindi basta-basta naglalabas ng premature na baby ha. Hindi yan kung yung tipong trip lang ni doctor na ilabas na natin yan prematurely, okay, para matapos na ang lahat. No, it doesn't work that way. Bago ilabas ang isang premature na baby, kailangan malaman muna ni doctor, makakahinga ba tong baby na 'to? Pag nilabas ba 'to ng maaga, kaya niya bang huminga? Kakayanin niya bang huminga? Mature na ba yung lungs niya enough to be able to breathe independently? Yun yung gustong malaman natin sa FL. So, hindi basta-basta naglalabas ng premature na baby ha. Ang baby, bago yan ilabas prematurely, the doctor has to know, will the baby be able to breathe? Makakahinga ba siya or hindi? So, paano malalaman ni doctor? Doon ngayon papasok yung FLM. Doon ngayon papasok si OD650. OD650 can be used, no, to assess kung mature na ba or hindi yung lungs ni baby. Pero either way, mag-iingat kayo kasi yung dalawang yan, gumagamit din ng spektro, gumagamit din sila ng magkaibang wavelength. OD450 ha, for the bilirubin in the amniotic fluid. OD650 naman kapag lamellar body count for the fetal lung maturity. Yan yung ilan pa lang sa mga wavelengths na kailangan nating i-memorize. At yung mga na-mention natin so far, sila yung mga dati nang nag-appear on the board exam. Kaya make sure you at least memorize them out. Kasi mataas din ang chance na mag-appear pa sila sa mga future examinations. Okay, so at least try to be familiar with those numbers. Okay? Pero either way, going back to the main issue, yan yung dapat tandaan sa mga wavelengths. Pero bottom line, gusto ko lang ipakita sa inyo no, na importanteng nagme-memorize ng wavelength. Kasi again, magkakaibang analytes gagamit ng magkakaibang wavelength. And since gagamit sila ng magkakaibang wavelength, gagamit sila ng magkakaibang light sources. So different analytes would use different wavelengths. Different wavelengths would mean that you will have to use different light sources. Okay, kaya kailangan or mahalaga na nakaspecify yung wavelength natin. So, yan pala yung unang reason kung bakit ang complicated ng pagme-measure ng light, no? Supposed to be dapat magme-measure lang tayo ng light, but it has become complicated kasi marami. Marami kasing klase. However, dagdagan pa natin ang problema niyo sa buhay. Isa pang reason kung bakit naging complicated ang pagme-measure ng light is marami kasing pwedeng gawin sa light. Okay? Marami na ngang klase ng light, marami pang pwedeng gawin sa light. Uy, ma'am, totoo ba na maraming pwedeng gawin sa light natin? Yes, ang light daw pwede siyang mag-undergo ng absorption. Pwede rin siyang mag-undergo ng emission. Pwede rin siyang mag-undergo ng fluorescence. Pwede rin siyang kumalat or ma-scatter, pwede rin siyang tumalsik or ma-reflect. Okay, ma'am, ano naman ngayon? Okay, eto ngayon yung reason kung bakit dumami ang instrument natin. Kasi may mga instrument tayo that is based on absorbance or absorption. Sino ba yung mga typical instrument natin na nagme-measure ng light na na-absorb? Light na na-absorb. Pag sinabi na-absorb, niyakap, kinuha. Okay? Niyakap yung light, okay, light that has been absorbed, yan ang principle ng spectrophotometry natin. At saka nung isa pa nating instrument later on, si AAS. Atomic absorption, spectroscopy, or spectrophotometry. Kaya pala tayo nagkaroon ng spectrophotometry at ng atomic absorption spectroscopy or sa ibang libro, spectrophotometry. It is all because of the idea na ang light ay pwede mong yakapin. Pwede mo siyang i-absorb. We call that absorption or absorbance. However, ang light daw pwede ring ma-emit. Pag sinabing ma-emit, pwede silang ma-release. Emission, otherwise known as release. Okay? And ito yung reason kung bakit nabuo ngayon si FEP. Okay? Nagkaroon tayo ng tinatawag na FEP. Bakit? Kasi ang light daw pala can undergo emission. Pag sinabing emission, release. Okay? Pwede silang i-release, pwede silang ilabas. So, pwede mong yakapin ng light, pero you can also learn to let it go. Okay, ang tawag natin sa pagle-let go ng light, we call it emission. Okay, so kapag niyakap mo, absorption, pag pinakawalan mo, emission, ang tawag dyan. Okay? However, ang light din daw can undergo fluorescence since ang light natin ay pwedeng mag-fluoresce or in layman's term, kumuti-kutitap. Nabuo tuloy ngayon si fluorometry. Fluorometry kasi measures light na nag-fluoresce or kumuti kutitap. Okay, so kumuti-kutitap, fluorescence, yan yung minimeasure na fluorometry. Furthermore, ang light daw pala, pwede rin daw siyang mag-undergo ng scatter. Pwede rin daw siyang kumalat. Okay, at yun naman ang magiging principle ng alin? Recall question to. Yan naman ang magiging principle ng nephelometry. Okay, ano daw palang minimeasure ng nephelometry natin? Nephelometry measures light na kumalat or na scatter. However, ingat, wala sa slide natin, pero ang light din pala, pwede rin pala siyang maharangan. Anong tawag natin sa instrument na nagme-measure ng light that has been blocked? Light that has been blocked, yan naman yung principle ng turbidimetry natin. Kanina sa nephelometry, kumalat lang. Pero kapag turbidimetry, naharangan mo na yung liwanag. Okay, so wala siya rito sa slide natin, pero I think nasa notes natin to. Light that has been blocked, yun naman yung minimeasure sa turbidimetry. Okay? Ang light din daw, pwedeng mag-undergo ng reflection. Pwedeng ma-reflect. Pwedeng tumalsik. Ano naman tawag natin sa instrument na nagme-measure ng reflectance or ng reflection? Light that has been reflected, syempre, this would be the principle of the reflectance photometry. Okay, so reflectance photometry or minsan reflectance spectrophotometry yung tawag sa kanya. Pero from the word reflectance, ang minimeasure niya is light that has been reflected, light na tumalsik, light na na-reflect. Okay? So therefore, yung pala yung reason kung bakit dumami ang instrument natin. Kaya pala nagkaroon tayo ng spectrophotometry at saka ng AAS kasi ang light pwede siyang ma-absorb. Okay? Kaya pala nagkaroon tayo ng FEP kasi pwede siyang ma-release, pwede siyang ma-emit. Kaya pala nagkaroon tayo ng fluorometry kasi pwede siyang kumuti-kutitap, pwede siyang mag-undergo ng fluorescence. Pwede rin siyang kumalat kaya nagkaroon tayo ng nephelometry. Pwede rin siyang maharangan kaya tayo nagkaroon ng turbidimetry at pwede siyang tumalsik kaya nagkaroon tayo ng reflectance photometry. In short, sino palang may kasalanan kung bakit ang dami nating pinag-aaralan? na instrument, kasalanan talaga lahat ng light. Okay, si light talaga ang may kasalanan no, kung bakit ang dami nating inaaral, dami nating nire-review. So therefore, kung nauurat na kayong mag-aral ng mga instruments, sisihin nyo si light. Si light talaga ang may kasalanan no, kung bakit dumami ng ganyan yung mga instruments natin. However, we'll try to deal with them one by one, pero doon muna tayo sa pinaka-basic. The mother of all instruments that measure light, yung ating spectrophotometry. Ma'am, paano mo nasabi na siya ang ina or siya ang mother of all the light-based measuring instruments natin? Kasi karamihan ng ibang instrument natin ay based sa spectrophotometry. Okay? They also share the basic parts of the spectrophotometer natin. So mamaya i-describe natin itong mga to. Pero for the meantime, start muna tayo dun sa pinaka-basic. The mother of all instruments, ano? Yung ating spectrophotometer. Spectrophotometer applies the principle of spectrophotometry, and spectrophotometry follows a certain law. Ano nga pala yung famous na law na sinusunod ng spectrophotometers natin? They follow yung law ng mga lasing. We call it the Beer's law. Or if you want the longer name, we call it the Beer-Lambert's law. And ano nga palang ini-state ng Beer-Lambert law natin? Ano bang gustong sabihin sa atin ni Beer-Lambert law? Okay, ganito yan. Meron kasing tatlong mathematical equation si Beer-Lambert law. Doon muna tayo sa una. Pakilagay naman dyan sa notes natin yung unang equation ng Beer's law natin. Beer's law states that your big A is equal to the small a times the small b times the small c. Ma'am, ano bang meaning ng A, B, C na yan? I think yung meaning nandiyan na sa notes natin. Big letter A stands for absorbance. The small letter A stands for absorptivity coefficient. The letter B stands for the path length. And letter C stands for concentration. So yan yung meaning ng big A, small B, and small c. Okay, ma'am. Ano bang gusto sabihin sa atin ng Beer's law? Ano bang gustong sabihin sa atin ng mathematical equation na to? To understand or to decipher the Beer's law natin, no? Para malaman natin kung ano bang gusto sabihin sa atin nitong Beer's law natin, chop-chopin muna natin siya. Ang absorbance daw, okay, pwede natin ang kulay. Ang absorbance daw is equal to the absorptivity coefficient. Uy, coefficient yan. Ang coefficient, kadalasan constant yan. Pag sinabing constant, meaning hindi siya nagbabago. And since hindi naman pala to nagbabago, temporary lang ha, temporarily tanggalin muna natin siya sa equation. Hindi naman daw kasi yan nagbabago, so wag muna natin siyang isama sa equation. Okay, since absorptivity coefficient is a constant, meaning hindi siya nagbabago, let's try to temporarily remove it from the equation. May gusto lang kasi tayong makita rito, no? Kaya temporarily, tinanggal muna natin siya. Okay? And then, multiply daw with letter B. Small letter B, ano nga meaning ng small letter B natin? Path length. Ano ba ibig sabihin ng path length pala? Path length actually refers to the thickness of the cuvette, thickness nung sample holder natin. Kung gaano kakapal yung glass na cuvette or yung plastic na cuvette mo, it is reflected on what we call the path length. And normally, pantay-pantay naman ang thickness ng cuvette, di ba? Ibig sabihin, constant din yung path length natin. Kasi normally, kapag si manufacturer ay gumagawa ng cuvette, pantay-pantay naman yung thickness ng cuvette natin. Meaning to say, the thickness of the cuvette, the path length should also be constant. Hindi rin siya dapat nagbabago. And since hindi naman siya nagbabago, temporarily, tanggalin muna natin siya sa equation. Uy, sino na lang naiwan sa equation natin? Ang naiwan, si big letter A, absorbance, at si small letter C, concentration. And uy, they're both in the numerator. And sabi natin, pag nasa numerator ang isang bagay, ano ang relationship nila? Pag parehas silang nasa numerator, they would be directly proportional. Since ang concentration ay nasa numerator, ano ngayon ang masasabi natin sa relationship ng absorbance at ng concentration? We can simply say that they are directly proportional. Yun lang pala gustong sabihin sa atin ni Beerslow, no? Pinahirapan pa tayo. Ang gusto niya lang palang sabihin is absorbance daw is directly proportional to concentration. Meaning, pag mataas ang absorbance, ibig sabihin mataas ang concentration. Pag mababa ang absorbance, ibig sabihin mababa ang concentration. Pinahirapan pa niya tayo, no? Yun lang pala gustong sabihin ni Beers Law. Gusto niya lang sabihin sa atin na si absorbance ay directly proportional to concentration. Okay, ma'am. Ano naman ngayon? Ano naman ngayon kung directly proportional sila with each other? Ito ngayon yung challenge. 'Di ba gusto mong malaman yung concentration? Concentration ng glucose, concentration ng triglyceride, concentration ng cholesterol. Di ba we want to get the concentration of the analyte? Ano sabi ni Beers Law? Gusto mo makuha si concentration? Kunin mo si absorbance at ibibigay ko sa iyo si concentration. Yun yung gustong puntuhin ni Beers Law. Gustong malaman ni Beers Law si absorbance kasi pag nakuha mo na si absorbance, maibibigay niya sa iyo si concentration. Okay, since interesado tayong malaman yung concentration ng analyte, ano munang kailangan? Kailangan makuha natin si absorbance. Ang tanong ngayon, paano natin kukunin si absorbance? How do we get the absorbance? Kailangan daw natin si absorbance para makuha natin si concentration. Ang tanong, paano natin kukunin si absorbance? Doon ngayon papasok yung instrument. Gagamitin natin si spectrophotometer. So dito, we will have to use the spectrophotometer. At anong sabi ni spectrophotometer? Ibibigay niya sa atin si absorbance. Okay, use the spectrophotometer to get the absorbance. And after that, si Beers Law na ang bahala. Si Beers Law na ang gagamit ng absorbance para makuha natin si concentration. So therefore, you will have to use the spectrophotometer to get the absorbance. At pag nakuha mo na si absorbance, itabi mo, si Beers Law na ang bahala. Makukuha mo na si concentration. As easy as that. Okay? So therefore, spectrophotometer promises to give us the absorbance at ito ang gagamitin natin sa Beers Law to get the concentration. Ang tanong, anong magic ang ginagawa ng spektro? Paano niya naibibigay sa atin si absorbance? Paano na ibibigay ni spektro si absorbance? Paano natin nalalaman ang absorbance gamit ang spectrophotometer? So para magawa ni spektro to, kailangan niya ng 5 basic parts. Which brings us to another recall question in the correct order. Arrange the 5 basic parts of the spectrophotometer. Ingat kayo sa mga libro, napakadaming parts ng spektro. However, etong babanggitin nating 5, sila yung 5 fundamental parts. Meaning, hindi gagana si spektro pag nawala ang isa sa kanilang 5. Ano pala yung 5 fundamental or basic parts ng spektro in the correct order? Starting off, first part is your light source. Naka-arrange na to dyan sa notes natin. First part is the light source, followed by the monochromator, followed by the cuvette or the sample holder, followed by the photodetector, and finally, the readout device. We recall question yung arrangement ha. Dati nung time ko nung board exam, naka-number yan. Naka-number, tas papapiliin kami which of the following numbers would describe the correct order of the sequence ng ating spectro photometer. So they would give you different numbers, sequence of numbers. Okay, kailangan i-arrange mo sila properly. At may reason May reason why they have to be arranged that way. Kaya make sure familiar kayo sa pagkakasunod-sunod ng mga parts ng spectrophotometer. Start tayo with the first one. The first one is your light source. As the name suggests, what's a light source? Light source is literally the source of light. Ma'am, ba't kailangan natin ng source of light? Well, hindi ka naman kasi makapag-measure ng light kung wala kang light source. So, kailangan may maglalabas ng light para sa'yo. Kaya naman kailangan natin ng light source. However, in your notes, maraming klase ng light source. Depende sa kaya nilang ibigay, sa kaya nilang ilabas. Okay, dyan sa notes natin, meron tayong mga light sources na nakakapaglabas ng visible, vis-IR, visible at saka infrared na range. Okay, in your notes, ano daw pala yung best example na nakakapaglabas ng visible infrared na range? Nandiyan na sa notes natin yung example, no? We have the tungsten halogen lamp. Tama ba? Nandiyan ba sa notes natin yung example? Baka mamaya sinasabi kong nandiyan, wala pala. No? Teka, let me check. Ay, okay. Nakalagay naman dyan. Okay, nakalagay na. For visible and infrared na range, we have the alin. For the visible and the infrared na range, we have your tungsten halogen lamp. Or by the way, minsan ini-specify nila kung sinong halogen. One of the important examples of halogen na pwede nating gamitin ay si Iodide. Iodide from iodine, kung naalala nyo pa sa periodic table of elements, ang iodine ay miyembro ng halogen family. Okay? So, wag kakalimutan, tungsten halogen lamp is one of the basic example no, of your light source, tungsten halogen, tungsten iodide na lamp. Example yan no, ng ating light source na nakapaglabas ng vis-IR. Again, pag sinabing vis-IR, visible and infrared na range.